account energy efficiency and environmental matters into reconstruction, not only does it contribute to making Beirut a healthier, more environmentally friendly city eventually later on, but especially for the victims of the explosion, these matters are important, and they will contribute also to their well-being in terms of the indoor environmental quality, toxicity, but also potentially significantly reducing their energy bills, the electricity and energy costs, which today we know all of these expenses are rocketing, and everybody is feeling the constraints imposed by the economical crisis. So we've put together this presentation with as many tips as possible. We try to really relate it to the current context, make it practical. We're going to try to also talk about cost when we have an idea about it. But if you have information from on the ground about certain challenges or things you want to share, please feel free to share them during the presentation. And we know that sometimes environmental solutions are more expensive and more costly, so there is an assessment to make. For some owners, it might be just a choice. They may be able to afford them. For others, it could not be possible, but we thought that we would still give all this information depending on the context, depending on the on who you are working with. And we are also trying to give tips which are not necessarily more costly, but still make the reconstruction more environmentally friendly. So in terms of the content, what we will do today, it's the seminar, the webinar will be divided in 3 parts. The first one will cover waste and materials and furniture. We have Mohammed Murtada, a sustainability architect, who will be covering that part. He works with us at EcoConsulting. The second part will focus more on energy efficiency and renewable energy. This will be covered by Sarah Jaber, also a sustainability engineer with EcoConsulting. And the last part will be about preserving our heritage. This will be covered by Mark Yared, an architect and restorer. And Mark has very nicely accepted to join this webinar and talk about also his experience on the ground, in particular focusing on buildings which are pre-1930s, so the ones we consider, traditional Lebanese architecture. That being said, I'll give the floor to Mohammed, who will start on the next part. Thank you, Mohammed.
Thank you, Maya. Thank you for the introduction. And we're going to start first with rubble management. So rubble is the most important part of construction demolition waste, and unfortunately it's not properly managed in Lebanon. There's no laws or practice that manages rubble sustainably. So usually rubble is constituted is usually concrete, masonry, tiles, and other mixed materials, and it's the largest part of construction demolition waste, which is part of construction waste. And usually it's illegally dumped at the dump sites on and offshore, and it can be sometimes used for projects for backfilling or for casting new concrete. So what mostly can be done with this types of waste is to sort it, and it can be reused then it can be reused in construction, or it can be sent to recycling facilities. So the most important goal here is to divert as much as possible waste from construction and demolition waste from landfills and from dumping in nature. So here we can see an example of crushed concrete that is used as rock filling, and it can be used also to, here in this example, it can be used to cast a new lintel or a new tiling for site access. And sometimes tiles, if they are removed in their original conditions, they can be reused in new functions, or they can be reused as they are in a new project. So if they are separated and sorted properly, they can be diverted from landfills. So the main challenges that face contractors to properly deal with rubble and construction demolition waste management waste is first, there are several hazardous materials that are present in the waste. So it might be dangerous to remove this waste and sort it and properly deal with it if the precautionary measures are not taken. Sometimes it's more costly and it's more time consuming to actually sort the waste and properly manage it. And sometimes if the waste is reused in construction, it might be more costly to actually recover the waste, to recover the resources from the demolition and reuse it in the new construction. It might be more costly than sourcing virgin materials. So it might not be the best incentive for contractors to follow that path. So in light of this event, so several bodies such as USG, the European Union, published several guidelines for safely dealing with the cleaning and reconstruction and the reconstruction process. First, we should be very careful and take no risks when doing these works, because to avoid any injuries to the people contributing to the cleaning. And it's very important to take all the precautionary measures in terms of wearing face masks, eyewear, protective eyewear, and gloves to avoid breathing in contaminants and dust, or cutting the skin with glass or other sharp materials.
Also, I would even
yes.
add here, helmets are extremely important depending on the conditions of the house, because we've seen a lot of false ceiling still, you know, hardly about to fall. So it's very important to have helmets too.
Helmets are really important. Yeah. So yes, all of these are very important to make sure that no injuries, and also the COVID-19 precautionary measures are also important, because we want to avoid spreading the pandemic in the cleaning process and in the reconstruction process. So another way to avoid the spreading contaminants is actually to cover all containers that are used to move rubble, and spray water over the rubble and demolition waste to avoid also spreading dust and contaminants. So one of the initiatives that are active in the reconstruction process, or in dealing with the demolition waste, is Recycle Beirut. They are actually contributing to the cleaning efforts, and they are collecting all the waste and sending them to a factory that will process them and produce new tiles from the glass. So this is tiles that are from old broken glass, and this can be used for indoor or outdoor paving. It can be used for furniture, and it also helps diverting waste from the landfill. So another initiative, part of several initiatives actually, is the AFDC Association. They are working on cleaning and sorting waste, paper, aluminum, and metal, and delivering them to Arc-en-Ciel, which have the facilities to recycle these materials and also divert waste from landfills. So glass can be recycled. Glass as a material can be recycled almost infinitely, and it doesn't lose its quality or purity during recycling. It's also more eco-friendly to rely on recycled glass than on virgin materials when producing new glass, and it can take many shapes. So it can be used to produce bottles or windows or whatever material whatever product we would like to produce. So unfortunately, glass isn't always recycled, and most of it is downcycled into aggregates and deposited in landfills. However, it can be some local initiatives are trying to recycle window glazing when it is separated from other types of waste. And And for example, here we can see Cedar Environmental with Ziad Abshakir are actually, they have taken 49 tons of shutter glass to Tripoli to recycle it into new products to give them a new life. So, so this is also a great initiative that is dealing with glass waste. And they are also picking up the glass, the clean glass that have been segregated from other types of waste. So this is the initiative that is recycling the glass. So this is Uniglass. They are taking the broken glass and transforming it into new products such as bottles and jars. And Arc-en-Ciel is one of the main recyclers in Lebanon, is also collecting glass in Quarantino. Now, moving on from after dealing with the demolition waste, if we want to look at the waste produced during reconstruction, the most important strategy is actually to reduce or eliminate the production of waste, because if we do so, we avoid having to reuse it or deal with the other parts of the waste management pyramid. So we can reduce the amount of waste by reducing from the source by, for example, ordering materials cut to size, or choosing materials that are environmentally preferable, such as materials that are not toxic, that have a lower environmental impact. And the second option is to reuse materials. So we can reuse materials that are generated on site with the new construction of other projects or the project itself, or we can also source salvaged materials or reuse materials from other projects in our construction site. The third option is recycling and composting, and the final two options are waste to energy, which is not good when it's incinerated. When incinerating waste, it's better when we are dealing with organic waste that is used to generate biogas. And the final option, which is the worst, is actually to dispose to landfill. So we should do everything to avoid sending waste to landfill. So moving on to the reconstruction, we're looking at sustainable materials, and we're going to look at sustainable materials for a structure. And we have two main areas that we can find sustainable materials in, which are salvage materials or sustainable materials. So here we can see in this example how they are using old telephone poles. So these are poles that are used for telephone lines, and they have been reused as beams to support a concrete roof. So if they are in a good condition, they can be reused as a structure. So this is a type of salvaged materials. Now, always when we are working with salvaged materials, it's always important to check for the structural integrity of the material, and that can be done with the advice of a civil engineer or by performing tests on the material to check if it can handle the load that will be designed for it. And so we can look for salvaged wood poles, we can look for salvaged steel beams. We can also reuse the rubble that is generated from the demolition to cast new concrete. But we have to take in mind that we have to process this rubble and sometimes grind it to a certain grain size to be able to use it in casting concrete. And also we can salvage bricks. So we can use salvaged bricks to build load-bearing walls. So also in Kerzai, they have used wooden poles to create a lintel over the window and the door. So this is another way to use salvaged materials as part of the structure. The other choice is using sustainable materials. So we can look for steel beams that have a high recycled content or they contain recycled content. Now, much of the steel in the market does actually contain recycled content. And it is not more expensive, it's actually the same price, but we can look for higher recycled content in steel to source a more sustainable material. A conventional option is to use locally produced cement, which means less transport of materials, and we can use concrete with rubble aggregates. So moving on to the partition and the skin, we can also look for salvage materials, and we can build a skin that is actually that has a higher performance. So here we can see in this example how the rubble, so the salvage blocks can be used in the construction of a new walls. So for example, this piece of wall, if properly managed or if properly cut, can be used to build a new wall or to create fencing or flooring, or it can or we can also the stone wall, so the stone sandstone that is in old houses or the stone blocks, they are generally not broken. They can be reused as they are in the restoration of old houses. So the second option is better performance materials, which can actually improve the insulation of the outdoor skin of the building. So double walls is the most conventional option, which is generally practiced in new construction in Lebanon. The second option is to look for high performance blocks, which are blocks that are made with cement and EPS beads, meaning fallin. So these are produced by Sibylline and they have a much lower weight. So although they're 2.5 times more expensive, they reduce 23% of the concrete costs because they are more lightweight and they reduce the need for a bigger structure. And since they have also EPS in them, they improve the thermal insulation of the walls. So this is an example of a double wall. When plastering the walls, we can look for a sustainable alternative that is earth plastering. So earth plastering is plaster that uses local clay, straw, lime or cement, lime and sand. We can also use cement to stabilize the earth in small quantities, in a small percentage. Now, it's important to remember that what's good about earth, mainly that it is cheaper than cement. We have a problem that cement is it's more expensive, and sometimes it's not available. So looking for using earth as a plastering is a great way to substitute cement. Now you can see here in this picture, we were in a workshop in Lersa in Jbel, where we actually we plastered a concrete block wall with earth. You can see the difference between the first layer and the second layer, which is generally smoother. So the first layer is mainly made to just stick on the wall, and the second layer is the finishing layer. And here this is the same from the same workshop. And generally, earth plaster doesn't require any expertise. So cement plasterers, plaster experts can actually apply earth plastering. And if it is done by unskilled labor, it can be labor intensive, but generally speaking, it can be applied by experts of plastering. And what's good about it is that it's cheap and it can be easily remodeled or removed. So if you want to change the plastering, we can easily remove it and cement with another material. And if we want to guarantee sometimes that the material will last longer, we can plaster over a steel mesh that will reduce cracking during cracking and shrinkage during drying. So here we tried several mixes for the plastering for the second layer. We tried several colors and several textures of earth plastering. And here you can see in this video how the earth plastering is done. This is like a more labor-intensive method. And here another project in Casa Batroun, we actually applied earth plastering to sandstone walls, and also later, like an expert in plastering, plastered the rest of the house steel mesh. So they use a steel mesh to plaster over it to create a more durable plaster, earth plaster. Now, moving on to paints and coatings, we should always look for water-based paints and low VOC paints and coatings, which have a much lower health impact on occupants because they do not emit much more VOCs. So we can look for much of these products are actually produced locally. So the paints that are produced by Tinol or Colortec are generally low VOC. And they are available in all colors, all textures, and for all materials. So they can be applied on wood, on walls, on metal. And also sometimes if you are looking for adhesives and sealants, we can look for important low VOC adhesives and sealants that do not emit harmful VOCs for occupants. So this is a campaign by Colortec that has been launched to show that what are the effects of oil-based paint. So it can create, so it can generate asthma or allergies with the occupants, and so it can affect their health negatively. And also, what's good about water-based paints they are not more expensive than oil-based paints. They are in the same price range, so they are really a better option than oil-based paints. So moving on to glass. Glass is responsible for a lot of solar and heat gain in projects, and since it's all imported, we can always look for glass that increases the performance of the building. So we can always choose double glazing, which can increase the thermal efficiency of the space up to 80%, and it can provide sound insulation and reduce the energy bills and heating and cooling loads. So the average cost of single glazing is $17 to $28 per square meter, while double glazing is $34 to $45 per square meter. So generally, it's not double the price. It can be actually more expensive, but it's not double the price, and they will pay for themselves in time by reducing the energy cost and utility bills. And if it's not economically feasible to install double glazing everywhere, sometimes it's better to we can just install double glazing for sunny rooms or sunny spaces to minimize the heat gain. So any rooms that are on the east and west that receive a lot of sun can have double glazing to increase their performance. Or we can have a reflective glass or single glazing reflective glass that can reduce the solar heat gains in these spaces. Or another option is to actually install louvers that would block the sun from entering the space.
I just want to add, guys, if you are looking when it comes to glazing, looking for options outside of Beirut is a good idea. So the lowest range here of $17 and $34, we actually found from a supplier through a social initiative in Tripoli. So this is something to keep in mind. If you look outside Beirut, you might find cheaper prices for the glass.
That's true. Actually, there is one initiative which is Betco that is trying to bring craftsmen from Tripoli and from Tripoli mainly to work in the reconstruction of Beirut in a way to help them, and sometimes because there is not enough craftsmen to work in Beirut, the craftsmen from Beirut only. So yes, moving on. So one initiative is Bab Shibak, which is trying to supply glass for the people that in the afflicted areas. And as a substitute to glass for temporary covering openings, We can use single-use plastic, such as nylon, which is not really sustainable because usually it is dumped in landfills. And the better option is to use fabric because it can be reused after when it is removed. And there is one business that is there is one fabric business in Lebanon, which is SCAF, that is donating fabric for the people that need something to cover their windows temporarily. Now, also we have to remember that nylon can be given to Cedar Environmental to be recycled as eco boards. So here, as you can see in this example, and so instead of sending them to landfill. Now, moving on to furniture. So when looking for sustainable furniture, we can always look for second-hand furniture, which is much cheaper and it's more environmentally friendly. We can look for furniture made from recycled and upcycled materials, or furniture made from sustainably sourced materials. So what's good about sustainable hand furniture is that it refurbishes old furniture and diverts it from going to landfill. So it avoids the need for virgin materials and reduces the amount of waste going to landfills. And what's good that we have a lot of craftsmen people that work in furniture restoration in Lebanon, and they are usually highly skilled. So we can make use of their skills to source second-hand furniture in our houses. So sustainable furniture has a minimal negative impact on the environment, or uses materials that have a minimal negative impact on the environment, and it can use sustainably sourced wood or reused wood. It can use materials that have a low impact. It can use a minimum amount or no chemicals that pollute the environment or affect the health of the occupants. And it can be sourced also locally or manufactured in a local factory to save on transportation. Here are some sources of second-hand furniture when we are looking for second-hand furniture in Lebanon. There is Second-Hand Beirut and Second-Hand Lebanon, which are two groups on Facebook. There's OLX that has a lot of second-hand furniture, and there is La Brocante, which is a shop in Damour that is full of second-hand furniture that is restored. This is an example of kitchen cabinets in Norway that use wood that was in a farm, and they reused that wood to create a kitchen counter and shelves. And so it creates this vintage look, and it's a sustainable choice as well. And what's good about antique furniture, that it's usually much more durable because it was made to last, and it's made from more durable materials. We can also use wood pallets that are used for shipping as a materials to create furniture, but we should always look for the HT label, which is heat treated, because a heat treated pallet wood is not treated with chemicals, so it can be safely used indoors. This is an example of how wood pallet can be used in furniture. This is an example in Alay, how they produced seating or produced chairs from wood pallet. Another option is to, there are several manufacturers of furniture from recycled fabric in Lebanon, such as Waste Studio and Tikaya. And here we can see in both of these examples how here they produce this poof, which is from billboard fabric. And here in this example, we can see that they produce cushions that are made from recycled fabric. And yeah, so these cushions are actually from recycled fabric, or fabric that is it's reused. Another way to look for wood or low toxicity furniture materials is to look for wood that has low or no urea formaldehyde. Urea formaldehyde is a strong VOC, so it damages the health of occupants or people that are in contact with this type of furniture. So we can replace that type of wood or that type of binding. Because urea formaldehyde is used for binding wood, we can use natural binding resins or phenol formaldehyde, which are safer alternatives for urea formaldehyde. These are the labels we can look for, which as NAUF, no added urea formaldehyde, NAF, no added formaldehyde, or ULEF, which is ultra low emitting formaldehyde. Now we're going to move on to energy with Sarah. Sarah, the floor is yours.
Thank you, Muhammad. Actually, I wanted to ask before we continue, if anyone has any questions for Muhammad's part, please feel free to ask them now, whether it's about waste management or materials or sustainable furniture or anything like that. So, حدا عنده سؤال؟
I have a quick question.
Yes.
You said cedar environmental an island to recycle, but where is it? Is it by Ziad Abu Shaker?
Cedar Environmental is a waste management consultancy, or yes, a waste management consultancy in Lebanon, and it is managed by someone called Ziad Abu Shaker, who is an important figure in the waste management in Lebanon. And they are responsible for a lot of initiatives, and they also help municipalities install several recycling plants and waste sorting plants around the country. So they are pretty known in Lebanon in terms of waste management and recycling.
And to add to this, basically what they do with the nylon, they actually take anything that is not recyclable, and they have a mechanism for shredding it and then compressing it to create these eco boards. They call them eco boards. Basically, things like nylon bags, plastic bags, the chips and chocolate, yes, packaging, Tetra Pak packaging. All of this is shredded, and and compressed in a certain way that it gives strength to the boards, and they can be used for outdoor furniture or any type of outdoor equipment, and boarding for anything, for landscaping.
Exactly.
Okay. Thank you so much.
Thank you. Any other questions? Okay, I guess the floor is yours, Sarah.
Okay, I'm going to share the presentation from my side in this case. Okay. All right, so now we will move on to the energy part. During the explosion, a lot of the AC units, the ducts, and the pipings in the affected buildings were also damaged. So part of reconstruction also is to look for energy efficient heating, cooling, and ventilation equipment. Now, we will focus in this presentation on rather small-scale equipment, because this is actually the case of most of the affected buildings, because a lot of them were either residential or offices, but not, not super large offices. Of course, there were some hospitals and some big buildings, but we will focus here on the rather small equipment. So normally, or the most common type of cooling system used is the DX, or the split unit, or the normal AC, where we have an indoor unit and a compressor outside. Now the problem with this unit and the regular AC is that the compressor is either on at full power or it's off. So basically, Whenever we need cooling, the compressor would be on at full capacity, يعني taking full power. And then when the temperature inside the space reaches the desired temperature, then it would turn off. The one better option instead of this AC is to use an AC with an inverter. So an inverter is basically a type of compressor which is able to regulate the power it needs based on how much cooling we need inside the space. So instead of just either turning on or off, it is able to regulate the power slowly. Yani when it is on, instead of consuming the full power all the time, it consumes exactly as much power as it needs. And this is much more efficient and reduces our electricity consumption by a lot. Actually, this type of system is able to save between 30 and 50% of the electricity consumed compared to a regular AC. So especially in a weather like, in a climate like Beirut's climate, where we have a lot of cooling needs, this can reflect really highly on our electricity bills. This is not only that, the other advantage is that a lot of us rely on the generator, and whenever we have the generator subscription, usually we have a limited amount of current or amperage that is available, 5 ampere, 10 ampere, something like that. So the other advantage of having an inverter, an AC unit with an inverter, is that it needs less amperage or less power to work, so it can turn on when the generator is on. So we don't have to turn the AC when the electric or the EDL electricity goes off. In terms of cost, it is more expensive than a regular AC by around 30%, which is not too significant, especially if you are a long-term resident or user of the building. And if you take this over the lifetime of the AC, then it will pay for itself quite quickly. The other type of system is called a VRV or a VRF system. And the idea here, it's a multi-split AC system. So basically, we have one compressor or one outdoor unit that is connected to several indoor units, which means one outdoor unit is serving several indoor spaces. And this outdoor unit is also a high efficiency inverter compressor. So not only we are saving space, but we are also saving in terms of energy. Another also advantage of this type of system is that it has the capability to provide cooling and heating at the same time. So we can be cooling one room and heating the other room at the same time. Now, of course, normally this is not the case in a house, for example, but if you take the example of an office where you have a data center needs cooling throughout the year, even during winter. So a VRV system is able to provide cooling for the data center during the winter and at the same time heating for the rest of the space in a really efficient way. So a VRV or VRF is suitable usually in offices or in other areas where we have many separate rooms that we want to cool, and we want to cool or heat. And we want the ability to control the temperature in each and every room separately. So they are useful in those type of spaces. They are quite costly, so they cost around 60% more than a regular AC. But you can save money on the pipework or enhance because you are using one outdoor unit only. So the pipework has to go from this one outdoor unit. The pipework has to go from this outdoor unit to the different indoor units instead of having each one of them separately. This also saves space on your facade. So instead of having a lot of compressors on the building facade, you are using less compressors as well. And like we said, it is a high energy efficient system. The final type of system that we will discuss is a heat pump. Now, the idea of a heat pump is very similar to the AC or the air conditioner, but instead of providing cooling, it provides heating. Okay, this is why we call it heat pump. However, the particular system that I am discussing today is a heat pump that not only provides cold air and hot air, but it also provides hot water. So this hot water can definitely be used for domestic hot water, for the shower, for the kitchen, etc. It is much more efficient than an electric heater or azan, or even a diesel heater or a diesel boiler. It's actually around 3 times more efficient than electric or diesel heating. It can also provide hot water for space heating, yani for the radiators. But for that, you will have to use low temperature radiators or underfloor heating. So the advantage of the system, like we said, is the efficiency, but also is that you are using one system. Does someone have a question? No? Okay. Yeah, the other advantage is that you can use one system to provide the heating, the cooling, as well as the water heating. So it's kind of a 3-in-1 system, and all of that is done with very high efficiency. This type of technology is expensive, and it's still a bit new in the market. Not heat pump in general, but in particular using heat pump for domestic hot water. However, we do have an incentive for installing such a system, which is a grant that covers 30% of the heat pump cost, of the whole heat pump system cost, if you are using Italian brands. So basically, this is kind of a coordination between Lebanon and the Italians, and they want to encourage Lebanese developers and users to use Italian efficient heat pumps. If you are interested in this, we can put you in contact with the LCEC, which is the Lebanese Center for Energy Conservation, and they are the ones who are managing this grant. Now, some final considerations in general when we talk about energy efficient systems. One that is very important is insulation. So even if we get the most efficient system in the world, if our pipes and our ducts are not properly insulated, then all of the cooling and all of the heating will just go to waste. So it's very important to make sure that we are insulating them well. A second thing that is good to mention is reused ACs. So we have a lot of reused ACs or second-hand ACs in the market. This is also something to be considered if money is an issue and you are looking for a more affordable option. This can be a good option. Of course, whenever you are buying something that is second-hand, you need to make sure that it is in good shape. In particular, the compressor is working well to prevent problems in the future. And you can have an AC expert look at it to make sure that it's working properly. Also, an important point to mention, whenever we think of cooling, we automatically think of the AC, but we have some other ways, let's say traditional maybe ways of cooling, which is using fans, in particular ceiling fans. So ceiling fans are a good way to reduce our dependency on the AC, especially during the moderate months. And in Beirut, we have a lot of a long time during the year where the weather is quite moderate and pleasant. We just need a bit of air circulation to help us get through the day. And ceiling fans don't have to be, the old fans that shake and make a loud noise. There are a lot of new fans that are more efficient and more aesthetic also to look at, and also don't have such a loud noise. And finally, it's important not to oversize HVAC systems. So it's not مش حيلا حطينا AC كتير كبير. The bigger is not always the better. On the contrary, when we are oversizing, we are increasing the cost. We are increasing shaft sizes or spaces that are needed in the faux plafond, in the false ceiling for ducts and pipes, and we are also increasing the complexity of the system. Okay, the final thing I want to discuss when it comes to HVAC is refrigerants and the choice of refrigerants. So first of all, refrigerant is the gas or the material that is present inside the AC unit. So for example, in your car, when the AC is broken, sometimes they say بدك تعبي لها غاز, or you have to fill it with gas. This gas is actually the refrigerant, and it's a material that is used to provide the cooling inside an AC unit. Now, the problem with it is that the traditional materials used as refrigerants have a very, very bad effect on the environment in two main ways. One of them is that they destroy the ozone layer, which, as you might know, is very important because it protects us from ultraviolet radiations. And the second way they harm the environment is that they increase global warming a lot. So we want to try to find alternatives to reduce or better alternatives for this refrigerant. Now, I'm not going to go into details with the technical names and how each one of these refrigerants behaves. In short, the best type of refrigerant is a natural refrigerant like CO2, like ammonia, like propane. However, these are not yet commercially available. So the second best that you can definitely find in the market nowadays are these type of refrigerants. They are called HFCs or hydrofluorocarbons. Or if you are in the business and you know the terms, you will most likely have heard of R134A or R410A. So these type of refrigerants do not harm the ozone layer. They still have a bit of a bad effect on global warming, but like we said, for now, they are the most feasible option. So if you are buying a new AC system, make sure that it uses one of these refrigerants. And the second thing you can do to try to reduce the harm is to actually reduce the amount of refrigerant that is needed. And you can do that in one of two ways. One of them is to reduce the cooling load. So try to, use double glazing or use shutters or size your AC properly so that you don't need a lot of cooling in your house. And second option is to locate the indoor unit and the outdoor unit as close to each other as possible. So the less piping we have, the less amount of refrigerant we need. Also, something important to keep in mind if you have an old AC, if you are using an old AC, is that you cannot simply change the type of refrigerant in the AC. So you cannot, if the AC is using an older version, an older refrigerant that is harmful, you cannot simply switch it out to a newer one. The whole compressor will have to be changed, and in general, it's not very cost effective because changing the compressor means paying more than 50% of the cost of the whole AC, so it's not always a feasible option. Now, if you want to know what type of refrigerant is present in any AC, you can look at the compressor. There is like a label on it which lists the power and all the information. You can look for the term R134A or R22 or whatever, and the most common ones are listed here. So you can refer to this table and see which type of refrigerant is present in your AC system. Usually they are written on the compressor outside and also on the indoor unit on the side. Okay, moving on to energy efficient lighting. So how can we reduce our demand or our energy consumption from lighting? One good way, which is actually a passive way to reduce lighting, is to make the most out of daylight. And this can be done by using a lot of windows if we can. And another good way is actually to use reflective room surfaces. So painting the rooms with light-colored materials will reflect the light more and will mean that we will need less artificial lighting inside the space. Another thing we can do is to direct the light to where it is needed. So this is called task lighting. So let's say we have an office space. Instead of just lighting up the whole room, we can focus on lighting the spaces directly above the desks of the people working, because this is where we need lighting. We can also make use of controls and sensors. We will talk about that in details in a bit. And of course, the type of the lamps that we use is very important, and we will also go over some of the energy efficient types of lights. So when we want to choose a light bulb or a light fixtures, what should we look for? The first thing is the average life. The average life is basically how long will this lamp last, okay? It is measured in hours, so you can say this lamp is 50,000 hours, 10,000 hours, something like that. And it will give you an indication of when this lamp will break or will need replacement. Of course, the longer the average life, the better it is for us, because we need to replace the lamp less frequently. The second important characteristic, which is essential when we talk about energy efficiency, is actually the efficacy or the efficiency of the light bulb. So basically, what we want from a light bulb is to transform electricity into light. And the more effectively a lamp does that, the higher its efficiency. This is measured in lumens per watt. So lumens is a unit of light, and watt, as you know, is a unit of power or of electricity. So the higher this number, the more efficient the lamp is. So these are the efficiencies of commonly used lamp types. You can see that the worst one is the incandescent lamp. So this is a very old type of lamp, and if you've seen it before, actually it heats up a lot. So this is why its efficiency is bad. It transforms a lot of the electricity it takes into heat instead of into light. And the highest type of, or the best efficiency is the LED light. And there is a lot of research going on and a lot of new products, and it is still improving and improving and increasing in terms of efficiency. Fluorescent is somewhere in the middle. Some other characteristics that are a bit more related to the aesthetic or to the look of the lamp is the color rendering index, or CRI. This measure is basically tells you how the color of the surfaces would appear under the light source. So if you have, let's say, a white paper, sometimes if you put it under a certain light, it would look more bluish or more yellowish. So basically, how accurately a certain lamp fixture reflects colors is measured by the CRI. It's an index. It's called RA, and it can go up to 100. Usually for residential applications, something above 80 is more than enough, unless you are really, you are working at a design studio or somewhere where color accuracy is very, very important. Then you can go up to 90 and above. We also have the color temperature, or the CCT. Now, the color temperature basically tells you the appearance of the light. Is it more white or is it more yellow? Sometimes it's also called a warm color or a cold color. It's measured in degree Kelvin, like a temperature, and it depends on your preference and on the design that you are looking for. All right, we will focus a bit more on two types of lights, which are the CFL, or the compact fluorescent lamp. Commonly in Lebanon, it's known as لمبة التوفيق, and the LEDs. We have different types of shapes and designs. So you have things that look like the traditional bulb, you have spots, you have tubular, you have also LED strips, and all different shapes and sizes. So they can fit whatever aesthetic you are looking for. Now, the best choice in lighting is actually the LED because of its very high efficiency and long lifetime. Actually, the payback period for installing LED is less than 2 years. Sometimes it's even less than 1 year. So they can definitely make up for their price in no time. In terms of safety, they don't have any mercury in them, which we will see is a problem with the fluorescents, and they can be recycled. Also important to note that they can be retrofitted to existing lighting fixtures. So even if in the existing building you had fluorescent or another type of lighting, in most cases the LED can be easily retrofitted without having to change the whole lighting system. The price for LED is around $2 to $3 per bulb if we are talking about a good Chinese brand. Of course, if you are looking at European brands, then it would be more expensive, but this is an average price. Now, in terms of efficiency, just to give you an idea, so this spot, LED spot, uses 5.5 watts, and it gives the equivalent light output of a 50-watt halogen lamp. So basically, you are looking at 90% savings in energy consumption just by switching out from halogen to LED. If we look at another example with the tubular LED or the T8, it can have savings up to 60%. So LED is definitely a very good option to go for. Now, fluorescence, the problem with fluorescence, or one of the problems, is mercury. So, and this is something that you have to be very careful about, whether you are looking at an existing buildings with broken fluorescent lamps, or even, you know, in your houses, or in the future, if you if this happens with you, then this is also something that is good to know. So all fluorescent lamps have a small amount of mercury in them, and you might know that mercury is actually a very dangerous metal, and it evaporates when the lamp breaks. It evaporates, and if you inhale it in large concentrations, it can cause problems with the brain and very serious health issues. So what you need to do is, of course, not touch it with your bare hands at all, and as soon as the lamp breaks, you have to open the window and ventilate the room for at least 5 to 15 minutes properly. Use gloves or a thick plastic bag to remove it and seal it. And ideally, we would send it to a recycling center which collects these type of hazardous waste, but unfortunately, this is not available in Lebanon yet. Okay. Something else to keep in mind in terms of energy efficiency for fluorescent lamps is that all fluorescent lamps require a ballast, which is also called a starter or a control gear. Now, the conventional type of starter is wire wound or a magnetic ballast. And if you've had fluorescent, you know, in some old houses, you remember that we used to call them لمبة بطارية, and they used to flicker a lot, and they used to make this buzzing sound. And yeah, so both of these things, the flicker and the buzzing sound, is actually caused by the magnetic ballast. So what can you do to improve that? You can actually use electronic high frequency ballasts. These can save 20 to 30% in energy for the lamp. They can also start up the lamp without any flashing. They increase the lifetime of the lamp. They don't flicker, like I said, and they have a silent operation. Now, most of the integral CFLs or compact fluorescent lamps already have electronic ballasts, but if you are using tubular fluorescent lamps, you have to specify that you want a high frequency ballast with them. Okay, after talking about the lamp types, we're going to talk about lighting control systems. So this is also one option of reducing the energy bills. It's by controlling the lighting. Instead of always counting on people to turn off the light when they leave the room, you can make it automatic and more efficient. And this is especially important, of course, in common spaces. So, for example, in a building entrance, in corridors, in stairs, in restrooms, in restaurants, for example, common rooms in offices, and things like that. So the two most common types of lighting control systems are the push buttons, which can be manually activated by users. So these can be used on stairs, for example. When someone wants to use the stairs, they would push the button. The light would turn on for, let's say, 5 minutes, and then it would turn off automatically. The price for such for a push button is around $15. The other type of lighting control system is the passive infrared control, or more commonly known as the motion sensor. So the motion sensor basically would detect movement whenever a person enters. It would turn on the lighting, and then it would turn off after a certain amount of time. These are very common in parkings, but also they can be used for stairs, for entrances, etc., etc. The price for such a system is around $30 if we are talking about a good, relatively good Chinese brand. But of course, if you are using a more European brand, then it can go up to $100 and more. We mentioned briefly task lighting at the beginning. So here we are talking more about how we can control lighting through the design of our lighting system. So if you have influence on the design during reconstruction, then something to consider is task lighting, which is basically focusing lighting where it is needed instead of lighting everything in the same amount. So in an office space, for example, you need some lighting for the whole space, but it doesn't have to be very high. You can focus the high lighting directly above the desks of the staff or the workers. The same can be done, for example, in a kitchen where you have the lighting above the countertops or above the bar area, and also using desk lamps at home. So this reduces the overall amount of light and directs it where it is needed. Another thing you can do is to control the lighting levels. So instead of just having one lighting level in the space, or basically one switch that controls the overall lighting of the space, the idea is to have more control over the lighting. So, for example, in this room, instead of having one button to turn on these 4 light bulbs, or these 4 areas, you can turn each one of them with a separate button. So depending where you are sitting and how much of the space you need, you can control each one of them separately. Another idea is to have, instead of, for example, this is an example from one of our projects where they had a swimming pool area. Instead of turning on all these spots at the same time, they controlled they skipped one light fixture and they connected it to one switch, and then the rest they connected them to the other switch. So they can either turn on half of the light bulbs or all of them, depending on the time of the day and how much lighting they need. Okay, now in terms of energy efficient appliances, of course, what we look for is A-rated or energy-rated appliances, especially when we're talking about fridge, washing machine, dishwasher, dryer, and these type of big equipment. The good thing is that A-rated equipment are not more expensive than regular appliances. So sometimes there's around 5% difference in price, and sometimes there even isn't any difference in price. Because they are actually available in many brands. So you can find, of course, the high-end brands that are energy rated that are expensive, but you can also find brands that are not very expensive that have the A+ and A++ rating. So when you want to look for an appliance, of course, you can ask the vendor, but you can also look for this label. For example, this label is used for a washing machine. It tells you the rating here. So this one is A++. It tells you how much electricity it uses per year, so 145 kilowatt hours per year. And also for the washing machine, it gives you some other information. So this is the water consumption per year, and then some other practical info like how much weight it can take, etc. This is another example for a fridge, where you also have the energy rating, how much electricity it consumes, and the other relevant information for the fridge, like the temperature and the sound levels that it produces. So it's good to ask about this when you are looking for appliances. We also wanted to mention that Khori Home is doing kind of an initiative to help people who were affected by the blast, and they are offering 60% on appliances, on certain appliances, not on everything. But we checked, and there are actually some of the appliances that are on offer that are A+ and A++ rated. So you can choose within this offer high-rated equipment. All right, the final topic we will talk about in energy is solar energy. So in Lebanon, we actually have a lot of sun. So it's a resource that is widely available. On average, we have 8.25 hours of sunshine throughout the year. Of course, it's higher in summer than in winter, but overall, we are considered to be in a very good place to make use of this sunshine. Now, the two most common and popular ways of using sun is either for water heating, using solar water heaters or solar panels, and the second one is to generate electricity through photovoltaics or PV. So when we talk about solar water heating, this should be, let's say, the starting point, because it is the least expensive type of renewable energy that you can use, and it is actually very, very, very good in Lebanon. So in Lebanon, a solar water heating system is able to provide 60 to 70% of an annual household's hot water needs. So this means that you are saving 60 to 70% of your utility bills instead of paying them on electric heating or a diesel boiler if you have a diesel boiler. This type of technology is also very cost effective, so it has a payback period between 2 to 3 years, and the lifetime for such a system is much higher. It's 20 to 30 years. So it's in general a very good system, and the majority of users are very satisfied with this type of system. This is especially useful for residential buildings, and we will see later, of course, it depends on the amount of roof space you have, but if you are able to afford this type of system, it is an excellent resource. It can also be used in bigger spaces where you have need for hot water, like hospitals, for example, where you need a lot of hot water. Then this can also be a really good way to get it. Some important things to keep in mind when it comes to solar water heaters is that you have to ensure minimum standards of collectors. So they cannot be just obtained from anywhere. Of course, you want high quality collectors to make sure that they will last long and give you the results that you are looking for. So it's important to look for the guarantee also from the manufacturer. The people who install the solar water heaters should also be qualified, and not just anyone. And also you have to take into consideration rainwater and natural elements, and leave space between the collectors and the roof tiles. And very important, not to forget to insulate the pipes. Okay, this is an example of a residential building in Ashrafiyeh where a solar water heater system, it was a collective system that was used for 16 apartments. So this was done kind of like a pergola above the roof. And this particular type of solar water heating system used vacuum tubes to heat the water. Okay. Photovoltaics. So the idea behind photovoltaics is that they produce electricity from the sun. There is a very high potential for this. The system is a good system. It doesn't need a lot of maintenance. It's pollution free during use, and it has low operating costs. However, to date, the setup costs are still relatively high. So it's not something that is as accessible as the solar water heaters, for example. We also have the issue in Lebanon that it's not always possible of selling. It's not always possible to sell the excess electricity back to the government. It depends if the electricity is on or not. So sometimes you will have to resort to batteries, and batteries are not environmentally friendly, and they're also not economical. Basically, for both of these systems, whether photovoltaics or solar water heaters, of course, when we talk about buildings in Beirut, if they are high-rise, you have to keep in mind that they need space on the roof. So this is the first thing to consider, whether you have space on the roof or not. Of course, the exact area needed depends on the application. But if we are talking about a low-rise residential building, then solar water heater is definitely a good idea. If we are also talking about commercial buildings that have a large footprint, like a mall, like a hospital, perhaps a hotel, then both solar water heaters and PVs can be considered. Both of these systems reduce the dependency on the electricity and generators, and obviously they reduce the energy bills in the future. Now, when it comes to solar water heating, actually I mentioned this already, so they are recommended for residential, especially low-rise residential, but they can also be used for high-rise or commercial applications where we need hot water, like hospitals and hotels. The photovoltaics are more recommended for bigger projects. Can be used for, yes, sorry. Did anyone want to say anything? Okay. So photovoltaics can be used for any type of project, but we are saying they are maybe more feasible at the moment for large projects like hospitals, hotels, or malls, because unfortunately they are still a bit expensive. Finally, we said that it's very important to have qualified people working on renewable energy and installing them. So in order to know who is qualified, the LCEC, or Lebanese Center for Energy Conservation, publishes regularly a list of qualified companies that are able to supply and install solar water heaters and photovoltaics. So you can go to the LCEC website and download the most updated list and choose a supplier and installer from that list to make sure that they are qualified and good. Finally, we wanted to mention this website by Make Sense, which provides a kind of database of all sorts of different services that are helping with the Beirut blast. So you can find things that are related to reconstruction and cleaning and recycling, as well as many other different categories. So you can use this to look for initiatives and to look for information if you need it. All right. So do you have, before I move on to, before I hand over actually to Mark, I wanted to know if you have any questions.
Yes, I have a couple of questions.
Please go ahead.
So, talking about solar panels, you said they have to be placed on a roof. But let's say in my case, I don't have the official roof yet, so I could imagine it would be very costly for me to set up the whole solar panel system. And then let's say in a few years, we would like to continue growing up. I would have to probably, it would just be bad. But is there anything else on the land, or let's say maybe if there's a second house or maybe some kind of a small house, I don't know, any other way?
Well, if you have space next to the house, they can be mounted on the ground. However, in general, specifically for the solar water heating system, I think this is the one you're asking about. It's much better to have it on the roof because sometimes you also locate the tank right above it. So if it is located on the roof, then you can make use of gravity for the water pressure instead of using additional pumps. However, even if you are in the future looking to expand your building and add another roof, then you can have additional piping and the panels can simply be placed on the higher roof then. It might need, some additional work later, but it is definitely feasible. There's no reason not to, it's not a reason to prevent you from putting it now.
Okay, good to know. But you also said that this system can provide you with the heating of the house. Is that correct?
Yes, so you can use the solar heated water to heat the house. However, in general, it's not enough. So if we are talking about if you have radiators inside your house, then the solar system can be used as kind of a preheat system. So instead of the boiler having to heat the water from, say, 10 degrees to 80 degrees, the solar panels would heat it from 10 to, say, 30 or 40 degrees, depending on the weather. And then the diesel boiler would take care of raising the temperature from 40 to 80. So you would still have like maybe 50% reduction in energy consumption, but it is not enough as a standalone system without the need of a boiler completely.
Oh, yeah, I understand that. Okay. And does it ever happen that there's excess of the energy collected by the sun?
Yes, absolutely. In summer, you definitely need like a release valve because the temperatures can reach up to boiling, especially in a climate like Beirut. So usually, this is the installer would have this. There's like a release valve to make sure that you don't have any issues with overheating.
Okay, I see. Thank you. And one more question about the AC compressors in inverter. I have fairly new AC units in the house. I would say I bought them about 3.5 years ago. I'm sure I have compressors. Can I buy just inverters, or is it something that has to be bought together, AC unit with the appropriate inverter?
Actually, no. Unfortunately, it's either the compressor is a compressor with inverter or it is not. So it's not something that that can be retrofitted.
So you have to buy the AC unit together with the inverter.
Yes.
Okay. Okay, thank you so much.
To be specific, it's the compressor, yani the outdoor unit only, that needs to come with the inverter.
Oh, okay. Okay, so it's not either or. Okay, so I have to buy just the compressor, new compressor with the inverter, or I would have to buy both, brand new AC with the compressor with the inverter.
So basically, just to clarify, when I say AC, an AC is composed of an indoor unit, which is the one that
Yes.
you see inside your space, and an outdoor unit. The outdoor unit is the compressor. Okay.
Correct.
So currently, in your case, the compressor most likely is a regular compressor. Either you will have to change the complete AC unit, or if you want, you can change the compressor itself and use instead a compressor with an inverter. But of course, you will have to check with the technician to make sure that it is compatible with your indoor unit.
Okay.
And in terms of cost efficiency, changing the compressor is already more than 50% of the price of the AC, just to give you an idea.
Okay. Thank you so much, Sarah.
You're welcome. Anyone else has any questions? All right, then in this case, I am very happy to hand over to Mark Yared to take us through the last part of the presentation about heritage buildings. Mark, please go ahead.
All right, thank you, Sarah. I'm Mark Yared. I'm an architect restorer. I've been working for the past 2 years on a heritage house in Jemaise in the Blast area. So I'm gonna share the presentation now. All right. So is it shared?
Yes, we can see it.
Okay, great. Of course, we're gonna talk about the heritage buildings in Beirut. First of all, I will introduce our team, the BBHR 2020, that has been working on the rescue of these buildings. And then a short introduction to Beirut's houses, so we know their typology and the construction techniques. And in the end, we're gonna talk about the interventions after the blast. First of all, we are the BBHR 2020 team, which stands for Beirut Built Heritage Rescue. We are a team of over 40, now over 50 architect restorers and engineers specialized in restoring these buildings. We also have a team of 200 architects and students in architecture that are helping us do the works. And the team is working under the official, in an official status under the umbrella of the DGA, that means the Ministry of Culture, and UNESCO. So the actions we're actually taking on the ground are grouped to multiple groups. First, we are giving the technical support on the ground for all individuals, the house owners, and the NGOs working on the reconstruction and the reparation. Second, we already did a large mapping of damaged buildings. Site assessment, urgent proppings, roof protection. So I'm gonna go one by one, starting with the mapping and architectural assessments. So by today, we have already assessed over 650 buildings, of which heritage buildings, I'm talking about the heritage ones, of which 94 are very, very damaged. And 46 of them are in risk of major collapse. So we are also leading interviews with the owners and site assessments, of course. After this horrible result, we also worked on the propping phase, which came directly alternatively with the mapping we did, and specifically for the buildings at risk of falling. So as we can see in the picture, that was on the left. That was the before photo of this house, and it was a cantilevered ceiling. So the risk of collapse was extremely high, and that required a fast propping intervention. Also, all the team is like volunteers, and also some of the contractors came willingly to us and offered help, so this work could be done. We can see also some other examples. The facades completely ruined, so the ceilings were loose, were broken, and needed urgent propping. Here, this particular facade was showing buckling, so it was out of plumb, and we had to make an urgent propping from inside and outside to hold the wall so it doesn't crumble. These are photos from inside. Also, how we blocked some openings, how we held walls, freestanding walls after the blast. As of today, 17 buildings are being propped. 12 are under study of propping. Let's move to roof protection and covering. Also, we have a group with roof experts actually doing surveys, and we localized all the endangered roofs, all the affected roofs, and we are taking action right now to cover and protect all the roofs before the rain season. So we have over 80 roofs damaged, and if the rain season comes, then the rain could infiltrate inside the house, and since the ceilings are all wood and plaster, this could be catastrophic. So this is one of the first actions we are actually taking, and hopefully in the next week this work will be already will have started. We have done a lot of surveys on the roofs to check all the anomalies, all the broken parts, how to apply the shelters. Also, we have a lot of volunteers that are offering materials for covering. Next, we also did missions to rescue some damaged items from important or from people that asked for it. This is a photo from the Patriarchate Orthodox in Beirut. We have a big team of archaeologists, students, architects that came for the help, and we organized ourselves inside those houses, and we rescued what could be rescued from the broken items, let's say from the windows, from the ceilings, from the Baghdadi ceilings that we will see in a few. And we also have a team that's working on the drone imagery and the 3D mapping of these buildings. In that way, we can help the engineers to better assess the critical situations, and it would help the process go faster. Also in this group, we have like 12 students also that were formed how to do the 3D mapping. This is the Sursok Palace, north rectification of its facade after the blast. Now we're gonna like do a small introduction on Beirut's heritage houses to better know their typology, what they're made of, their construction materials, and their sustainable properties as well. And it's really important to highlight how sustainable and durable the materials are. So first of all, we have the central whole house that is characterized by its 3 arches opening. It's pitched roof. It's a stone construction, of course, and it's some of its facades are mostly plastered with lime plaster that we will see in a few. And then we have the mandate architecture. It's some sort of evolution of the central whole house. It also has a central whole house typology, which revolves around a central space, and all the rooms are distributed around it and interconnected to it. And then it evolved to become the veranda type, also a more later type of buildings. And of course, we have the high vernacular, which is on the left, and the supra-vernacular, which is the high bourgeoisie palaces, like the Sursok Museum. We have some of them also in Beirut. They have the same properties, materials, but are way more ornamented, way more crafted, and more spacious, of course. Let's go through some very important elements in these houses. Like here we have this protruding element on the facade. It's called the bow window. We can see it here. And we have these buildings as well that are the transitional phase from the 40s to the 50s. Let's talk about the materials of these houses. As we can see on the facade, it's basically stone construction. It's a sandstone, which all the Beiruti houses were very famous of. And we can see the marble slabs and the wooden shutters. Okay, and in the interior also we have the plaster, which is like decorated and painted. We have the Baghdadi ceiling also. The Baghdadi ceiling, which is a composition between a wooden structure and the lime support. So the wood plays a role to support the lime, and the lime finally is a face where they can paint, and it holds everything together. And also the cornices are made of gyps. These are some examples of the Baghdadi ceilings. They are all wooden structures on top of the lime, and the lime is interconnected to the wooden structure. We have also wall plaster and paints. We can find very rich decorations as well as very simple walls. It depends on the clients, on the owners, on the artists that came to the house and worked.
Mike, we have someone asking to what period do the buildings belong?
Which period?
Yes. So these
of course, the central hall house has started the late 19th century, in the late 19th century, let's say in the late 800s, and spread until the 1930s, I think, 1930s, and developed to the buildings we saw, the veranda type, and later on the international style. So here we can see the cornices, gypsum elements, also highly decorated and highly ornamented. Even on the outside, they used to put gypsum elements. We have the beautiful handrails and steelwork, also ornamented, and it's all wrought iron. So very high laborers and steel workers used to craft the metal. We have ornamented openings and colored glass that we can often find in some of the triple bay arches, specifically this red color. The corbels are the stones that holds the marble slab of the balconies, and also they are connected to the facades. We have different types of tiles. This is the terracotta one, the cemento, of course, with all their shapes and colors. And here we can see the marble ones with the black slates between them, separating them. And under we can see the stone one. We call it furni. Furni tiles. So the final part, it's about the interventions after the blast. These are really durable materials, the ones we saw, and they have very specific properties, and they should be handled with real care, and they should be respected in order to preserve the authenticity of the house and to preserve the structure of the house, in order not to create further decays in the future. So we're gonna talk about the rescue and conservation of damaged materials. And finally, after we finish, we were gonna see the general intervention guidelines. So in some of the houses we've been working on in the past months, we've been sorting stones in the rubble. We can see the corbels we talked about a moment ago, how we sorted them, the marble, the wooden frames, and the wooden elements from the three arches, and also the normal stones, even keystones from arches, from windows. We sorted everything, and these stones should not be thrown away, because it's really expensive to find similar stones, and they can be reused. Broken stones can be cut, so it's important to keep them and sort them. This also implies for tiles. So if we have broken tiles or like a displaced slab, we can easily number the tiles, put them aside, and then remake the slab and reuse them. For the marble columns, this is a case of numbering of the marble columns in situ. So we could know the order of the broken pieces in order to reattach them, if possible, in the future intervention. because as much as we save from the original material of the house, it's always better as conservation approach. We have the wooden beams as well, so we shouldn't throw every broken wooden beam. In fact, we can save a lot of them. We can reuse them. We can cut the rotten part, the broken parts, and then reuse them in place or in other places. And this is a characteristic of the heritage building, heritage buildings in general. So nothing should be thrown. Everything can be reused. It's all recyclable. Here we can see the wooden pieces from the 3 arches. And this is what we should do in all the cases, because in the end, they could be reassembled. The same for the wooden shutters. Even if they're broken, any carpenter, any skilled carpenter can reintegrate new wooden elements to it, and we can reuse everything, literally everything. This is an example of a reassembling of 3 arch wooden parts. So it's very doable, and that's what should happen in all the houses. And also, this is a workshop reusing all the fallen parts, the wooden parts. For the Baghdadi ceiling, as we saw in the rescue mission we did, we should for sure save all the important elements, all the pieces that could be replaced in place. Maybe the small ones will be lost, but if it's a very important art piece, then why not save it up to the last fragment? Those are examples of art pieces that we are trying actually to find the pieces and to save, to make the collage. This is an example of tile sorting. Those tiles were numbered, were sorted, and then in the intervention they're gonna go back in place. As well as for the roof tiles, we've seen a lot of people throwing away the roof tiles. They thought that they're all broken, but even the broken ones can be reused. They could be cut and reused, like 20% of the 10%, 20% of the roof tiles are actually cut roof tiles, not complete ones. So we should keep them and to be used. The same for glass. For instance, here we could see some fragments still holding on the 3 arches. The same for the debris. We could look in it and find complete pieces. As for the very broken ones, it's really hard to reassemble. But as before me, they were talking, so we could like recycle glass. We also have the handrails, which we talked about a few moments ago. We could see it hanging here. And also we've seen a lot of people abandon these beautiful handrails, and this shouldn't be done. They should be like kept, even if broken, even if they're not straight anymore, because it's very expensive to remake wrought iron handrails. We should preserve them at all costs, put them aside and restore them and put them back in place. The same for the accessories. The accessories today are extremely rare and expensive, like the door handles, and every small little accessory should be kept, should be looked for and put aside reuse. Even if the window was heavily damaged, the door, all the wooden items were rotten, we should keep their accessories. That's really important to note. The same for the furniture. They should be kept, restored, because they are part also of this heritage that belongs to these houses. So the general intervention guidelines, here we can see a restorer working on a lime plaster in a Baghdadi ceiling. So that was before the explosion. But it's a good example how to use lime plaster in lacunas, to fill lacunas or to complete missing materials. So the main durability properties are the breathability. These houses live on breathability. If it was liquid or vapor, all the constructive materials in these houses are water permeable. That means the water comes in and then goes out. So it's very important not to block the cycle. If we do, then this leads to multiple problems, mainly condensation, rottening of materials, decaying of the stones. It should be really taken care of, the breathability of all materials added. So the houses also have good management of humidity, and in management of humidity, also the breathability plays a role, but as well lime plaster and lime mortar plays a very important role in this management, because lime is really decreases the humidity levels. Aeration as well. So roofs are mostly aerated, walls are aerated, wooden elements are like have big aeration properties, and we shouldn't seal those houses. So we should leave it really aerated, and so sealed elements should not be added to the houses, and we will check it in a moment. Good thermal properties, because of its big openings on the north facade, it gives beautiful natural lighting and minimum sun exposure at the same time. So we have a beautiful lighting from the north side, because it has this beautiful 3 arches on the north side. In the same time, it has this beautiful element from the back. It's called the Liwan, and it's a wintertime seating area where the sun goes in through multiple windows. And it's a rather small space. So in terms of thermal properties, it's well thought, and it's always in the neutral array. Another property is the masonry's flexibility. So all the construction elements, mainly the masonry, because it constitutes the biggest part of these houses, are very flexible and then withstands deformations. And by this we mean they can resist to multiple elements and multiple factors, such as let's say seismic activity, high winds, pressure, and even this blast, they really did well. But really, it's a first for these buildings. Finally, they are recyclable and biodegradable materials, and we should say this again: nothing should be thrown; all can be recycled in the heritage houses. So it's a wonderful thing about them. So how to avoid intrusive interventions and stay on the safe and respectable interventions for these houses. So how to be more conservative for the houses, what to do, what not to do. Before any intervention, we should ask ourselves if the intervention or the action we're actually applying would affect any of the properties that we shown before, like the flexibility, the breathability, the aeration, all of them. So one of the common mistakes are using cement mortar for repointing or for construction in these houses. So cement mortar is way harder and way more resistant than sandstone, and sandstone is the main element in these houses. So what will happen is that the cement mortar will stay as it is, and it will affect the sandstones in a way that it will eat the sandstone. In another word, it will cause big damages to it. So it really shouldn't be applied at any cost. Lime mortar, shown on the right image, is the right sustainable intervention to make. It's the breathable material to use. It bonds the stones together. It is of natural origin. It is stone in origin, and it goes back to its original state with time. So it's very important to always remember to use lime mortar and even plaster. This is for the plaster. Also, a common mistake is to use cement plaster. Cement plaster will ruin the breathability of the walls. So when the sandstone would breathe in the water or absorb the water, this will lead to the water being trapped inside and to have condensation on the other side. So it's really not good for the stones, for the beams, for everything. And by beams, I mean wooden beams. So if the water stays inside the walls, then the beams would rotten. So we should use lime plaster for the plastering actions, and leave the walls aerated, leave them breathable. Also, a common mistake is to use steel wire meshes that could lead to become rusty, or that doesn't really match the lime properties. But in fact, we have the fiberglass mesh, and it's a mesh that is highly compatible with lime plaster. And by mixing these together and by applying fiberglass mesh plaster, it could bring a very resistant and very high structure properties to the wall. So in case in case we need to consolidate a part of the house to fortify a wall, this is the right way to do it, to use fiberglass mesh with the lime plaster. For the openings, aluminum should not be used. So most of the people directly will go to aluminum, but for these special houses, the heritage buildings, aluminum is a mistake, because also it will affect the properties of the buildings. So it will we have the wood, that breathable materials, natural materials that could aerate the house and keep it breathable and not sealed. The most important, not sealed. We have concrete blocks. The usage of concrete blocks is not really welcome inside these houses. and not really compatible with sandstone construction. So instead, we should use the sandstone or any compatible stone with its entourage. If we're changing a lintel, we could use a more harder stone, a limestone. But for the walls, we can use mainly the sandstone. For the roofs, also some people would rush to concrete or steel because maybe they think it's more, it has more strength properties. But in fact, it's also a mistake because wooden roofs breathe, and it's also a very important property for the roofs, and it's all interconnected. Let's say the roof doesn't breathe, that means the Baghdadi under it doesn't breathe, and it will affect all the structure of the Baghdadi, even the coloring layers, the wooden beams would also change behavior. So it's important to keep the materials as they are, true to their original state. And finally, I hope that we could manage to restore as much as possible and bring back together the pieces. And we are here for any technical support, the BBHR team 2020.
Thank you, Mark, for this very interesting presentation. First of all, I would like to see if anyone has questions. I have a few, but I wanted to check if anyone from the participants has specific questions. No? Well, Mark, I wanted to ask you, I mean, given the current situation, how exactly this work is being undertaken? I mean, do you have enough experts in renovating these type of buildings in order to be able to manage with all of these, unfortunately, disastrously destroyed heritage buildings? How are you managing with that?
Yeah, well, in fact, we have a big team of volunteers, architects and engineers. Over 50 specialized architect restorers and engineers are working all together, dividing themselves in groups, so this work could be done. And each group is leading a task. Like I've shown before, some of them are working on the mapping, some of them are working on the 3D modeling of the buildings, and some are working on the propping on site with contractors.
Okay.
Yeah. So and others are leading also rescue missions for the pieces, for the broken pieces.
Yeah. And I mean, who is funding this in terms of the heritage buildings? Is this support received from abroad, or is this something that, I don't know, private philanthropists are funding? How is it working for all of this?
I know, in fact, for this, until this moment, it's all volunteering. And really? It's great because, it's just crazy, but everyone was really kind and very, the motive was huge. So everyone rushed to help and gave their best, and up until this moment, so it was all volunteering, the BBHR.
Yeah, but in terms of materials, cost of materials, you didn't have to purchase anything so far?
Very, very few purchases. It was all given by contractors presented themselves. Material companies gave us support. It was all free.
That is amazing.
Yeah,
absolutely amazing. Okay, these were my main questions. I don't know if anyone has something else to say. I just wanted to add with regards to earth plastering in the previous presentation, if anyone is interested by knowing more about earth plastering and the formula that we had used in previous projects for earth plastering in terms of the proportions of clay and sand and lime, etc., you can send us an email because we can give you this information if you need to, if you're considering this instead of cement plastering. And I'm sure also the team in the Beirut Heritage recovery team can also help on these type of questions if you have specific questions, more technical.
Of course.
Yeah. Thank you. Thank you very much, Mark. Thank you, everybody, for participating. We are going to actually try to put this on YouTube in the next few days so that if you know anyone around us who may have missed it and is interested and couldn't join, it can circulate also for more information so that people who are on the ground and involved in reconstruction can perhaps benefit from all of the information that we presented, along with the information, the very valuable information that Mark has given us.
All right. Thank you. Thank you, everyone.
Thank you, Mark. Thank you, everybody.